is, the name of this talk has changed, but the content really hasn't changed much over the past really year since it's existed. But this is Agile testing basics for non-testers. Whole point being that testing has become a big part of Agile projects, but projects don't always have dedicated testers. So this is kind of to get you started on all of the thinking like a tester, doing like a tester without actually teaching you how to test, because nobody can really teach you how to test, but I can teach you the concepts and I can teach you some techniques to help you get started. So a little bit about me. It says here I've been testing for about 8 years. I actually think it's more like 10, but I can't remember, so we're gonna go with 8. Because I had a job that was kind of a hybrid as my very first role. I just recently joined a company called Coveros. We are an Agile consultancy. We do development work as consultants, and I am a trainer. So what I do now is I go around the country teaching testers how to test better through a series of certification courses. And I'm also developing a course, and I'm very excited about it. Previously, I was with Progressive Insurance. I never met Flo. Everybody always asks me. I never got to meet her. I am a cat mom. I'm very proud of that. I'm married to a cat dad. I'm a deacon. I love pro wrestling and I love punk rock, and I'm really into web accessibility. And that cupcake is a sticker that I give away, and I'm so sorry I'm not there to give it to you, but if you want one, I can have them shipped to Kevin and he can give them out at the next meetup.
I'm not giving those away.
Aw.
I'm keeping them all for myself.
Okay, you can have all the shinies you want. So before we get started, I just want to get you guys into thinking like a tester. Throw out for me the cases that you can think of for this login screen. What would you do if you were testing this?
Just yell it out.
Empty
Put in
screen.
valid
log
data.
in with nothing, log in with no username and password.
Wait, there's too many people talking at once.
Log in with no username or password.
Okay, good. What else are we going to do?
And ASCII characters for the password.
Good.
Input
What else?
validation.
SQL injection testing.
Nice. Okay, so those are good ones. There's also don't put in a password, don't put in a username. There's a remember me button. What happens if we click that? What happens if we try registration or lost your password? So those are all things that we can do here. And there's a lot of different ways to play with it. So what do you all think testing is? Tell me what you think I do as a tester.
Try to find bugs.
Break things.
Testing is verifying that the application works the way it's supposed to work.
Okay, so that is a very technical definition, actually. ISTQB defines part of testing as verification. They also define validation as two different things. Somebody said, look for bugs. That is something that I do. Somebody else said, did I hear break things?
Yes. Find the edge cases.
Find the edge cases, okay. Did somebody say break things? I thought I heard it, I'm not sure.
Yeah.
Okay, so here's the deal with saying that testers break things. I don't break anything. I don't touch your code. I expose that it never worked in the first place. So these are my thoughts on testing. I almost always hear when I ask this question, people say checking or validation or verification. Testing isn't just checking. There are certainly times that I use a checklist, but for the most part, really good testing is about exploring. It's about going into the application and adventuring through it without direction. It's about looking for all of those workflows that we forgot about. I have a really good friend who tells the story of a company she used to work at. They did a whole bunch of work, put out this whole new feature, and immediately started getting calls, you broke the upload. And this was a music service. You would upload, musicians would upload music and it would go through some sort of scanner. And she said, how did we break upload? I'd used upload, it worked fine. Well, it turned out that there was a workflow that like 90% of their users used that no one in the technical group knew about. It was built before they started working on the application. No one knew it was there, and they took their entire user base down simply because they didn't understand how their user used the app, because they didn't do enough exploration. So a huge part of testing is exploring. A lot of people say look for bugs, that I'm a bug hunter. I'm here to tell you I am not a very good bug hunter. It's not my skill set. There are some testers who are fantastic bug hunters. I am not one of them. What I am really good at, as opposed to giving you bug-free software, is giving you good enough quality. Good enough quality is this idea that we acknowledge that things aren't perfect, but we've also gotten it to a state where it is good enough for our users. And we're going to talk more about that in a second. And testing is definitely not only looking for bugs. In fact, looking for bugs is a side effect of testing. It is an end result, but it's not what we actually set out to do, especially in an Agile framework and in an Agile setting. Instead, what we're doing is we're looking at usability, we're looking at accessibility, we're doing user advocacy. So there could be bugs there that affect no one. If there's a bug that affects no one, I don't care about it. I'm probably going to document it and I'm going to give it to you, but then I'm going to say, when we get around to it, we'll fix this. Because I don't care as long as my user is okay and the application isn't at risk. And then another big part of testing is this idea of risk identification and risk mitigation. And we're going to talk a lot about that because risk is a huge part of Agile testing. It's part of what allows us to be flexible enough to get a product out the door and still balance the timeframes that we need to work on and sprint lengths and making good decisions about what matters and what doesn't. So I'm going to keep talking to y'all. I'm going to make you talk to me all night. How many different test types and test methodologies do you think there are? And I'm going to tell you, I don't know the exact number. There are enough out there that I don't know, but give me a guess.
More than one.
There's definitely more than one.
25.
Okay.
50.
50. You know, 50 is closer. This is what I call the incomplete wall of testing. This is like the great wall of methodologies. And there might be something in here repeated. Somebody told me that once and I haven't fixed the slide. But there's things on here that I've never done. Like I've never done fuzz testing. I know people who do it, but I've never had a reason to. I've never done destructive testing. There are enough different types of testing on here that I haven't touched all of these in the 10-ish years I've been testing. So let's get into what you really came for, which is how to think like testers, how to communicate with your testers. So we're going to start with vocabulary. You've probably seen some of these terms before. At least I hope you've seen some of these terms before. So unit testing, we know that that's closely coupled to the code. It isolates section of code to verify its correctness. It technically falls in the realm of testing. I don't particularly believe that it's truly testing. Reason being, it tells us a whole lot more about code quality and whether you are meeting your coding standards than it does about whether something actually works. You can write a unit test that'll pass with code that shouldn't pass it. And that puts us in a situation where it's testing, but it's only partially testing. It's really not validating or verifying software. But then we get to functional testing. This is where we're really doing some testing. This is where we're actually doing verification and validation. So this tests against the functional requirements, and it's our very first line of testing. And I would hope as developers that you're doing at least some amount of functional testing on your projects. When I worked for Progressive, we actually had a rule that the developers did all of the functional testing. So they needed to sit down and create a test plan, and they were given a structure for it. And they did all of the functional testing on what they built. And then I went in and I did the next level of testing. So it took all of that nitpicky direction-based testing off my plate so that I could do really good exploration. So the next thing I want to talk about is smoke testing. Smoke testing and sanity testing, I have seen confused by people more times than I can count. Everybody likes to interchange them, but they are very different things. And they're probably two of the most misused pieces of terminology in the testing world. So smoke testing tests only the most critical functions of your application. This is like if somebody was testing a ventilation system and they held up a smoking stick, which is actually what they do to test ventilation systems, all this is doing is passing through the highest level functions and making sure you can get to the end. Your smoke test typically is only run after your code is built and after you elevate to production, because it tells you very little. It's just telling you that the most basic functions are up and working, and potentially the most critical if you have things that are super, super critical. Sanity testing, on the other hand, tests only your new functionality. So if you were to build something, a new component, whatever it may be, put it out there in your application and just test that section, that would be sanity testing. If you then went outside of that new function that you built, you'd move on to regression testing, because you're actually leaving that little tiny new piece of functionality and testing the way it interacts with everything else. So regression testing is this interesting thing. Regression testing's purpose is actually to make sure that you have not introduced any regression into your application. Has anyone ever heard regression testing mentioned that way?
Yes.
Somebody in the back has. Okay, cool. So I have to tell you, I used regression testing wrong, like as a term, for probably the last 10 years of my career. It wasn't until I went and I took this ISTQB program and actually had to learn this the official way that I realized that we use the term regression testing as this like catch-all. Everybody's like, well, I built this new thing, so I need to do regression. Well, no, that's not actually regression testing. What regression testing actually is making sure that when we build something new into an application, we haven't backslid. We haven't regressed our software back to a previous point or regressed to old bugs, old issues, old functionality problems. But in a generic sense, a lot of people use it as the term to say, we're going to go ahead and test and make sure that everything's still okay. So typically regression is just testing a recent code change. It's making sure you haven't adversely affected any existing features. But you're probably also going to see your testers talk about it as, we need to do regression testing because we're getting ready to go into an elevate, even though that's actually maintainability and maintenance testing. That's a whole nother story. Ooh, I went the wrong way. There we go. So some of those terms that I just talked about, we're going to use here. This is the software testing pyramid. This is a different pyramid than a lot of you have probably seen. Has everybody seen a different software testing pyramid previously? Have you seen the software testing pyramid before?
See this one? See this one?
Is that the cone of something or?
Yes, you've seen it upside down, right? The other way?
Yeah.
Okay. So this is kind of one of the new school versions of it. There are others. Actually, my friend Jenny, who works for Willow Tree Software, they do theirs as an ice cream cone. But it's all, essentially we're talking about the same thing, no matter how it's displayed. I like this one because it includes some things a lot of others don't include. So at the bottom, we've got these automated unit tests, your component level testing, just like you expect to have, right? Now here it has these dotted lines that are actually just meant to separate component from integration from API. But I like this because I really feel that where all of those dotted lines are, that's where we should be stopping and including some manual testing. Everybody loves to build automation and then just let it go. The problem is that automation requires additional testing. When we build automated testing, we have to test the tests. How do I know that your automation suite is actually testing anything? I helped on a project when I worked at a previous job where we went through and we actually did some testing against some tests that we had had existing for 5 or 6 years. We found out that of the 400 tests that were running, 300 of them auto-passed. They tested nothing. They did nothing. And even if they encountered a failure, they still passed because it was coded into them to pass. So we need to, when we're doing these automated testing, when we're doing automation around component testing, around integration testing, around API testing, we really need to spend some time testing the tests and also doing some exploratory testing before we build automation in, especially when it comes to API testing. crazy thing that happened to me once. I worked for this company that did geolocation servicing and was in the telematics industry. So they had customers that would have API suites and integrated with their application. They had a whole bunch of front end features to keep people from being able to screw up these particular functions. They didn't have anything on the APIs. So I was just messing around because that's what I do as a tester. I find things to poke at and I poke them. And there was this function of driver list. So you'd have a fleet manager and then a series of drivers. And I said, okay, well, cool. I've got these 2 fleets to play with. And I said, what happens if I take fleet manager from fleet A and make him a driver in fleet B? So I ran an API test and I was like, oh, cool. So fleet A now becomes a child of fleet B. But what happens if I take fleet manager from fleet B and put him in fleet A? Well, now I have a recursive loop. Those 2 fleets disappeared entirely from the application and brought down the database. So we had exposed to our customers, without even realizing it, the ability for them to cause a recursive loop, lose their driver list, and potentially take down our databases with no protection against it. Now, you might say, well, who would ever do that? But we're talking about customers here. Someone's going to do it, right? If I can come up with it, a customer can come up with it. I guarantee it. So then above these API tests, integration tests, component tests, we have the automated GUI tests. This is where you're running Selenium or Cypress or whatever your GUI layer testing is. There's a whole bunch of different suites out there. Some people are even like spending a whole bunch of money and getting things like Test Plant. But most people are doing Selenium. And then above that, in its own little world, is this manual session-based testing, the testing that I love, where I get to go explore. And I like that this pyramid has that separate because it really is its own thing. All of this other stuff is automation. All of this other stuff is potentially having me test the test, but all of this is going to be part of a suite intended to make sure that you don't have regression. Whereas this manual session-based testing is really where we spend some time discovering all of the things about the application we don't know. Because automation can tell you what you know. So when you build automation, you build it around what you know. But when you're testing by hand, when you're testing manually, you can discover all of the unknown unknowns, all of the things you had no idea about, like the workflow that your customers are using that you had no idea existed. So I said we were going to come back to this idea of risk. And before we go to risk, does anybody have any questions on the test pyramid? No? Okay. So testing is about risk. And it's not just testing that's about risk. Agile is about risk. And I think that's an important distinction. Everything we do in Agile development is about risk and about determining what risk looks like. So there's a couple of different ways to determine what risk is. I happen to like this one. We use 3 factors. Complexity. The harder it is to build, the more complex it is, the higher the risk. If your software is spaghetti code, it's riskier. If your software is an application that sits in the middle of 4 other applications, it's pretty high risk. The history. Do we know that this application is really flaky? Have we had a lot of problems with it? Do we not really know what we're getting into? If you don't know what the history is, that automatically becomes a bigger risk. And then the impact. So a lot of people say, well, the impact of things going down, but it's not just that. It's not just the technical impact. It's also your brand impact. How much is this going to cost you if it goes badly? And I'm not just talking financially. I'm talking, think about Boeing. What does it cost your brand? What does it cost your futures? Think about Equifax. How much trust do your customers lose in you if this doesn't go well? And if the impact of it is, well, they can't see the help text, then we're not too worried. If the impact of it is we've exposed hundreds of thousands of social security numbers or airplanes fall out of the sky, that's pretty significant. So I think out of all of the factors of risk, impact is actually the most important, because ultimately it's about the bottom line. It's about protecting our brand. And it's about protecting our livelihoods. If your brand is terribly tarnished, you may not have a job the next day. Not because you missed the bug, but because the bug cost the company everything. So now that I've made it a downer, you take those three factors and that gives you your total risk. Now, I like using numbers here. There's a couple of different ways to do this. I think it's Google that uses a heat map. So it goes from red to green, red being highest risk, green being lowest risk. I don't love it. And I don't love it because one, if you're colorblind, that means very little to you. And two, even I, as somebody with color vision, can't tell you the difference between orangish red and reddish orange. Which is higher risk? And what do they mean? Same thing with the positive side. What's the difference between greenish yellow and yellowish green? I don't know. I don't know which is higher risk. I don't know which is lower risk. It's just a mess to me. So instead, I like this number pattern that my former employer used, which is they scored each of these between 1 and 5. So complexity could be between 1 and 5, history 1 and 5, and impact 1 and 5. And then you take those numbers, you multiply the impact times either the complexity or the history, whichever is higher, and that gives you your total risk. So you're going to have a score between 1 and 25. And I'm sorry, I wish I had the slide in here that shows the numbers because it makes it easier, but does that scoring make sense?
Yeah.
Okay, cool.
One quick famous bug I'd like to add in. There's like a Ariane 5 rocket that exploded because a digit overflowed. That's literally why it exploded.
Mm-hmm. So that that's a specific kind of testing that would have found that bug. Needless to say that that impact is really high, right? There's loss of life. That's a major, major, major concern. And also when you're talking about things that have to do with safety, risk is a whole different conversation. Like in the medical device industry, in the aviation industry, in the auto industry, risk is done very differently than the way I did risk working for an insurance company or working for the telematics company. But you would use boundary testing to identify things like that number overflow, where you're looking at the boundaries of what's an okay case, what's the middle case, what is not acceptable. That's a whole specific type of testing. It's a technical skill. So risk gets us to this idea of good enough quality. I know not everybody likes Sheryl Sandberg. I happen to love this quote. I heard that done is better than perfect because done is a finish line. Done is your MVP. It's what you and your team negotiate together. And done can be something that changes. So I like to think about this as running a marathon, which, by the way, I don't run. Like if I'm running, you should probably run too because something is behind me. Like for real. So you're not going to go from me, who doesn't run, to a marathon the next day. But what I might do is go from the couch to a 5K, and then a 5K to a 10K, and then a 10K to a half marathon, and then a half marathon to a full marathon. And each of those are a definition of done. And each of those can be negotiated and moved and changed as we need to. And just because we hit that definition of done, that final definition that we planned on, which is the full marathon, there's more we can do. I could do an ultra marathon. I could do an Ironman. I could do a Spartan race. All of those are new definitions of done based on truly completing our MVP. Your risk and your risk definition is going to determine your definition of done. So if you say, you know what, we've got these 5 bugs left, but they're super low risk, I'm really not worried about them, and if someone hits them, it's not that embarrassing for us, then you've hit your definition of done. However, if you have a whole bunch of bugs open and some of them are user can't log in, or user gets kicked out of the site, or the database goes down, well, you probably haven't hit your definition of done, right? So that's something you have to negotiate as a team. You have to keep discussing that together. And this is really important because perfection is a myth. Yes, there's such a thing as deterministic software. You can get to know bugs, but I don't think any of us have ever worked on an application that was bug-free. It just doesn't exist. And if we were to try and get to the point where an application was bug-free, we would never release software. We just never finish the job. So we have to come up with this, we have to get to this idea of good enough quality and say what's acceptable and what's unacceptable and get work out the door. Give me 1 second. So let's shift over to actually testing. I was up until recently a test lead. So I led a team of testers. It was a small team, but it was a team nonetheless. And I always asked them to sit down and go through these questions before they started testing. And if you're a developer who's asked to do some testing, I think this is a really, really good little survey to go over with yourself. So your introduction, which is basically saying what your test basis is. This is saying, I plan to do X. And then what are you testing? Well, I am testing this thing. I added a new feature to the login screen. Maybe it's Facebook login to the login screen. So what am I testing? I'm testing Facebook login. What does it apply to? It applies to login and Facebook functionality. What's my goal? My goal is to prove out that a user can effectively log in and register using this Facebook login function. What are my required resources? Well, I have a feeling that if you're doing Facebook login, you probably need Facebook Sandbox. You might need another sandbox as well. Maybe you need some special GUIDs created for you. Maybe you need an API. Maybe you need a tool. Whatever your resources are that you don't have readily available to you, that would go there. And then what's out of scope? And this what's out of scope is really, really important because it's very easy for testers and even developers doing testing to wind up going too broad. It's great to explore. It's also really important to not be wasteful. So what's out of scope? Well, the other login functions are out of scope. Google login's out of scope. Doing anything past login is out of scope. It's really important to keep yourself on track with exactly what you're supposed to be doing. Now, that's not to say that there isn't a time for exploration. There is. But in this case, that's not what we're trying to do. So who here has ever heard the term charter for testing? Anybody ever heard a tester talk about using a charter? Okay. Well, charters are my favorite way to test because, like I said, I love exploration. So testing with charters is a time-boxed approach. So you're probably going to say, okay, I am giving myself an hour to test this. And once that hour is over, I'm done. If there's more things to explore, or if I find something that I need to spend some time on, then you would start a new charter based on that new stuff that you need to narrow down to. We also say that this is session-based because oftentimes you want to create multiple sessions within your time box. So I'd say, okay, I'm time boxing myself to an hour of testing. I'm giving myself 2 half-hour sessions. The benefit of those sessions is that it gives you an opportunity to do new things. So the first time, maybe you take one workflow to try and complete the task you're trying to accomplish. The next time you take another workflow. So session-based gives you the opportunity to vary up your testing. Charters are risk-based and risk-focused. So you're going to say, okay, well, what are my highest risk items here? I want to focus on those. I want to spend a little less time on the mid-risk, and I'm going to spend almost no time on low risk. Probably going to touch them. I'm going to spend very, very little time on them. And this is intended to invite exploration. When we're going to talk about how to create a charter in a second, but the idea of it is to invite a wander through the application. This is also a really, really good opportunity as a developer to pair with a tester or to do pair testing with other developers. It lets you see how they think and it lets them see how you think, and it helps you identify where the gaps may be in your testing or in your development. So I love this conversation I had with James, which is why I include it. He has this idea of enough-driven working, and that's what session-based testing with a time box is. It's enough. It's trying to get to a point where we're not wasteful and we're doing good enough quality without waste. So I have this phrase that I use, and some people say it's corny, and I don't care. But I say that testing with a charter is like using a treasure map, and testing with a script is like using a GPS. With a treasure map, you kind of wander out, and it says, okay, in 5 paces, you'll find the X. And of course, the X is never 5 paces away because everybody's footsteps are different, and that map was created before a building existed over your X. So you have to go wander and explore and find new ways to do things. We're still defining our test objective. We're still saying my plan is to do this. This is what I need to accomplish, but we're doing it in a very open-ended way. And we do that by using guiding questions. So instead of saying log in, Gesundheit, instead of saying log in, click this button, then click this button, then put this item in your shopping cart, we're saying log in and find a way to get to the shopping cart that you've never used before. We're saying, what happens when you delete all the items from your shopping cart? What happens when you try and do some weird behavior? So you use open-ended questions, or things like create a scenario when, find a way to hit a breakpoint, find a way to hit a crash. So we use these open-ended guiding questions that sort of lead people down a path without telling them how to get there. Compare that to scripted testing, which again defines your objective, but it's step-by-step instructions, much more like using a GPS. And here's this thing about scripted testing. I threw out this term pesticide paradox. This is one of the 7 principles of testing. I believe it was Black who wrote these 7 principles, but I can't tell you for sure. But one of them is the pesticide paradox. And that's this paradox that we can go testing in the same place in the same way over and over and over again, and you're going to clear all those bugs. But once you've cleared all those bugs, bugs exist somewhere else. Or once you use the same data set multiple times, you've cleared all of the bugs that you could find with that data set, but there's new bugs that you've never found because you've never varied outside of that data set. So when you use scripted testing, you really, really, really run the risk of getting into this pesticide paradox. You also run that risk with automation. When your automation doesn't use varying data, you run the risk of missing things because you're not varying it up enough. So this is a functional test script. I actually need to change this out. I totally forgot. But this is just saying, here are step-by-step instructions to get to the specific thing you're doing. This was an application I worked on a while ago, but it says if you're on the specific selection page, then the agent code radio button is selected and the person's logged in. They have more than one CCR level, and that gives you expected results, the type of test. This is a positive case, which means we are expecting it to work. And then he also included the status, which is complete. This was created by a developer who does amazing testing. I actually joke with him. I think he's a better tester than I am. There's also, you could also put negative tests in here. So things that you intend to not work, like, oh, the user is going to do this and then it's going to give you an error. So it's important to have both positive and negative tests because you don't want just happy path. And this looks very similar, but this is a functional test case. So instead of having step-by-step like the previous one, this is individual actions. So if you're on this particular page and you navigate to the login, you should see this specific thing, again, saying it's a positive test and what its status is. And then the next test condition is its own unique action, just like the previous was. So automation. Automation is great. Automation, when I was testing full time, could make my life much, much easier. However, automation is not always the answer. So you want to automate your repetitive tasks. You want to automate the things that your testers have to do over and over and over again, or you have to do over and over and over again. Because testing the same thing over and over and over again sucks. I'm just being honest. There is nothing that will make a tester more disengaged than running the same test back to back to back. However, automating your repetitive tasks, you still have to make sure that you're varying your data. You want to automate your pain points. If something's really difficult to test, this is when you want to build automation around it because it makes everybody's life easier and it's way more likely to get tested as often as it needs to be. When things are really hard to test, people sometimes avoid them, and then you run into big risks of not covering all of your risks. But automation can't tell you everything. Automation can't tell you how your application feels to a user. It can't tell you if it's accessible to everyone. There are automation tools for accessibility, but you're still only getting about 30% of accessibility issues. The rest of them you really still have to find by hand. And automation can't tell you your unknown unknowns. I shared that story of the workflow that nobody knew about. Automation will never tell you that. And that was actually the situation that they ran into. They had this automation that they just kept running because they trusted it was covering everything, and it had this huge gap. So I'm going to open up the floor. I went through a lot of stuff very quickly, but do any of you have questions for me about testing in an Agile environment, about what it's like to make a really weird career transition like I did? I see someone in the back.
Yeah, how much do you use charter-based testing versus scripted testing?
So it depends. My previous job, when I worked for Progressive, they worked exclusively in a charter-based environment. They did risk-based testing as a company-wide strategy. So 90% of my testing was charter-based. I'd say a better balance is probably 75-25, 75-ish% doing exploration, 25-ish% doing checklist based around what you know your highest risk items are to make sure they're covered.
So there's different tools for trying to determine what your coverage is for your test over your code. So what is your test coverage for your code overall? Usually it gives you a percentage. And do you have a typical guideline as to what that percentage should be, at least a range?
Well, here's where it gets tricky. If you're doing TDD, you should have 100% code coverage.
Yep.
Otherwise, strive for 100. Be happy with 50 to 75. But it depends on your strategy. If you're doing ATDD or TDD, ultimately you want to be at 100% if you're in those environments.
I have a question about testing notes. Or sometimes developers will leave notes for testing, and I feel like there's a dichotomy of do I give you exactly the cases that I've described? This is how you prompt this error. This is how you get the habitat, or do I leave it more vague? What are the variables exactly, so that I'm not necessarily influencing the decision making of the tester? Does that make sense?
So there's this thing called tester independence, and it's a philosophy of some of the thought leaders in the testing world. The testing needs independence from development. However, we need independence, but we also sometimes need direction because we're not in the code.
Right.
So I feel like rather than testing notes, it's better to have a conversation. Here's the data that I tested with. Here's where I think here's what was toughest for me to build. That's always a really nice thing to know. And whenever I sit down and talk with a developer before testing something, I always ask them, what was hard for you? What happened that you didn't expect? Where did you find something strange? So it's important to share that, but it's also important to share, I tested with this data, or just so you know, this particular thing only works this way right now. You kind of have to balance with influencing their decision-making and giving them information that they have to know to test something. If it's required to get through the test, then give them that data. If it's not, then let them go figure it out. And if they're lost, they'll tell you. And that's part of building a good relationship with your testers, is getting to a point where there's enough psychological safety that your testers feel safe coming to you and saying, I don't get this. And I would do it to developers all the time. I'd be like, this doesn't make any sense. Why can't I do it this way? Oh, I didn't tell you that this particular feature doesn't work right now. You have to do this weird workaround. But you have to be safe. You have to create enough safety for that to be okay. What
Anyone
else?
else?
Yeah. So I've seen, you brought up a good point about independence of testers, and that also kind of reminds me of past testing with users where you observe a user actually going through it, a real user, without giving them any prompting. Just say, hey, ultimately purchase something, and you watch how they get there. But then there's automated tools that do things like create a cool heat map, overlaying the web pages so you can see where people are spending most time looking and things like that. Do you ever use any of those tools or any of those methodologies to observe users, either remotely or in person?
So I have had the awesome benefit of getting to sit in on user lab sessions where I actually got to see users interact with the application. Both user lab is in usability and user lab is in accessibility. Those heat maps can be helpful, but they can also be, they can also deter you from doing the right thing. The way your user is going to use your application has a lot more to do with the user than it does the application itself. So if you're going to use things like the applications that tell you where people are clicking, you need to get a really, really good cross-section of your users, because the way someone who is, let me put it this way. So there's a persona I like to use when I talk about accessibility testing. I call her Maria. Maria is your grandma, essentially. Her first computer was her phone. So she is she's a late adopter to technology. She's new to using it. The way she uses your application is going to be different than the way I use it. And you've got to make sure that when you're doing those kinds of broad spectrum coverages of the way your user interacts, that you've got a big spectrum of your user base, or you're going to miss workflows. And you're going to miss things that actually matter because you haven't covered enough bases. So you've got to make sure you get all of the age groups. You get a good cross section gender-wise as well, because it can vary. Especially like, I know if I'm buying something, I will put it in my cart and take it out of my cart over and over and over again, which is different than the way someone older than me is probably doing it, who puts it in their cart and just buys it. But I'll put it in my cart, I'll think about it, I'll change my mind, I'll take it out, then I'll get a coupon, then I'll put it back in. So you got to make sure you're covering all of that. That wandered a little bit, but I think you get where I'm going.
You're saying to use more of like the observation in the user lab sessions, like observing the users more so than the heat map data and things like that?
Yeah, and I like that because not only am I seeing where the user's clicking, I'm also seeing how they got there. So how long did it take them to sit down and look at the page to figure out where to go? Which a lot of those applications that do like heat mapping and stuff don't tell you. That was especially important in insurance because there's a lot of directions and a lot of like verbiage on the screen, and we needed to know how hard it was for them to figure out where to go.
So have you had to test bots yet? Because that's an interesting type of interface. And to me, it seems like it might be, you're almost having to do a script-based type of testing for that.
What kind of testing?
Bots, like virtual assistants and the like.
You know, I haven't had to do that. There is a lot of conversation about machine learning and AI and testing AI and machine learning systems. I'm going to be honest, I'm just not enough of a techie for it. So I haven't gotten involved in those. But follow like Jennifer Bonney on Twitter or Tariq King or Angie Jones. They're talking about a lot of that right now. By the way, just follow Angie Jones anyway. She's amazing.
Cool. Have you ever used like we've been playing with the idea of something called Gherkin, where it's like it's sort of like scripting, but more like English sentences that map to code that developers write. Have you used that at all, and any experience with it that you?
Yeah. Oh, yeah. We were using we were doing TDD at Progressive, and so we used Cucumber, we used Gherkin. Yeah, absolutely. It's a really, really nice way to structure your requirements. It's a really nice way to write your automation. and it gives your testers a good test basis to work off of, and it helps them write user-based, user story-based tests really nicely. Yeah.
When you were using the BED type of tools like Gherkin, were you like pairing developers in testing? How did you write the tests?
So we did something really odd. They were trying to make a transition to Scrum, but teams were huge. So I was on one team that had 100 people on it. There's a lot of people in IT at Progressive. These teams are enormous. The projects are enormous. They're way too big for Scrum. The team that I was a test lead on, we had 25 people on the team. So what we did was we kind of used Spotify's model in a weird way. We created little mini teams within the team, and that paired 3 developers to 1 tester. Idea being they would develop their own shared vocabulary within their little group. So they knew how to talk to each other about things, which was great. They understood, like if say Erica, who was one of my testers, went to her developer and said, this is broken, they understood what this is broken meant because they had a shared language, which takes time to develop. So it is definitely worth it to pair testers and developers, but it's also really important to get developers doing some of their own testing so that they become better developers.
I was kind of wondering too.
Yeah.
When you're using the BED, just follow up with Gherkin, things like that. Are your testers typically writing the word-based type part of the test, or is it developer doing that, and the developer writing the code part of it?
So I had the benefit of having automation engineers.
What's that?
I had the benefit of having automation engineers.
Okay.
Each team had 2 embedded automation folks, so they did that. But the developers wrote their own unit tests.
Okay.
Now my testers they didn't do any automation. So business analysts wrote the requirements, testers did exploratory testing, automation wrote automation code, and developers wrote code. It's a very traditional way of doing things, but you know, fintech is slow.
Anyone else? All right. Well, thank you, Jenna.
You're welcome. Thank you for having me. Hope I wasn't too boring.
From the questions, it was really good.
Awesome. Well, if any of you happen to be coming to Agile DevOps East or West, I will see you there.
Who's going? All the hands better go up. All right, I'll work on them, Jenna. We'll get them there.
Okay. All right. Have a great night, everybody.
Good night. Thank you.
Jenna does not need to be here for our boring giveaway.